This video is to review the questions on the Q1 Cumulative Practice Exam. Number 1 is asking us to categorize these numbers in the most precise way that we can. So let's go ahead and start with the square root of 10. So anything that is a square root, you have to look at, is it a perfect square or not? If it's a perfect square, you can take it out of the square root. If not, it's always irrational. Okay, and if you're not sure, you can always even use your calculator to help you, right? So if we put in second square root of 10, we see that it's not a perfect square because it doesn't end in just a whole number. There's numbers after the decimal. So even though the numbers after the decimal stop on your calculator, they keep going. Your calculator just rounded it. So because it's not a whole number, this number right here is irrational. So again, just to summarize, if it's not a perfect square, it means the number goes on forever and it's irrational. Okay, so looking at the second one, we have negative 17 over 3. So anything that can be written as a fraction and it can't be simplified to a whole number is rational. So a fraction or a decimal that ends or repeats is rational. 3 is natural. So a natural number is any whole number greater than 0. So 1, 2, 3, 4, and on. Okay, here we have negative 15. So it's a whole number, but it's negative. So a negative whole number is an integer. Oops. Integer. Okay, so the last one, when we have a number and we multiply that times 10 to a certain power, that's our scientific notation. Okay, so if we move on to number 2, so it is asking between what two consecutive whole numbers does the square root of 31 lie? So a whole number are numbers like 1, 2, 3, 4. There's no numbers after the decimal. Okay, so for a square root to be a whole number, it has to be a perfect square. Okay, so if we look at what is a perfect square that is less than the square root of 31, the first one is going to be the square root of 25. And the reason that the square root of 25 is a perfect square, because a number times itself can equal this number. Okay, so if you take 5 times 5, it equals 25. So the square root of 25 is 5. Now if we look at a number bigger than 31, that's a perfect square. The next number is the square root of 36. So 6 times 6 equals 36. So the square root of 36 is 6. And that means that the two consecutive whole numbers are going to be 5 and 6. Okay? So then if we move on to number 3, we're dividing a fraction divided by another fraction. So we have to remember our rule. So when we divide fractions, we keep the first fraction exactly as it is. We change the sign and we flip the fraction. Okay, so that means we keep 7 over 5. We change division to multiplication, and we flip the numerator and the denominator of the fraction. So we could just multiply across and simplify, or you can look and see, is there anything that can simplify before you multiply? Okay? Because the 5 is in the numerator and denominator, it can just cancel out. So 5 divided by 5 is just 1. Okay, so we just get 1, and then we can multiply across. 7 times 1 is 7. 1 times 1 is 1. And we end up with 7. Okay, so then if we move on to number 4, okay, simplify the radical expression 15 square root of 5 minus 17 square root of 5. When we add or subtract numbers with square roots, you have to first say, can I even do it? So in order to add or subtract, you have to have the same number under the radical. And this is only for addition and subtraction. So for addition and subtraction, you need the same number under the square root. Okay? And so because we have the same number, yes, we can subtract. And that square root stays the same, and all you do is subtract your coefficients. So you subtract your coefficients. Okay, so we have 15 minus 17 equals -2. Okay, and then the the radical stays the same, so your final answer is -2 square roots 5. So basically it's just telling you how many square roots of 5 do we have. Well, your coefficient tells you that. So do we have a number that matches? We do. Okay, so that's 4. We're going to go ahead and move on to 5. So number 5 is a matching. This first one, we're multiplying. So you have to be careful. You do not use the same rules when you multiply and divide as when you add and subtract. So when you multiply, you are going to multiply your like terms. So I'm going to multiply my coefficients first. Okay, so 2 times 3 is 6. So we multiply the coefficients, and then you multiply your number under your radical. Okay, so you keep your square root, right? And we just multiply those numbers under the radical. So 3 times 2 is 6. So 6 square root of 6, then you say, can I simplify this number under the radical, or can I take out a perfect square? And I can't in this case. So the answer here is 6 square roots 6. Okay? So here, okay, we have another adding question. So first off, can we add? Yes, we can, because we have the same number under the radical. So now we just have to say, how many square roots of 3 do we have? So we add our coefficients to tell us how many. Okay, so we have 2 plus 4, which is 6. And we just keep our square root of 3. Right, so this is the right answer for that one. Okay? So next, now we have another multiplication. So remember, we multiply our coefficients first, and then we multiply the numbers under the radical. So when you don't see a number here, it's really like saying it's 1, or in this case, -1. So we can take -1 times 7 and get -7, and then we can take square root of 3 times the square root of 3. Remember, it still goes under the radical. 3 times 3 is 9. In this case, though, the square root of 9 is a perfect square because 3 times 3 equals 9. So you can actually say that that's the same thing. I'm going to write it over here. That's the same thing as -7 times 3. So because the square root of 9 is 3. So -7 times 3 equals -21. Okay, so that's the answer right there. Okay, so -21. Now this last one, we're subtracting. So again, can we subtract first off? Yes, we can, because we have the same number under the radical. So now how many square roots of 3 do we have? Well, let's look at our coefficients. So we have -2 and -3. So -2 minus 4. You could also say that's plus a negative, right? So -2 plus a -4 is -6. So we have -6, and we just have that many square roots of 3. Okay. So now if we move on to number 6, here's a scientific notation question. It wants us to find the product, which that means multiply, right? So we're multiplying. We can show you 2 different ways to do this, okay? You could just plug this into your calculator, right? So you could, let me get rid of the glare. Okay. So we could say, well, 3.1. Can you see that okay? So 3.1, second E. Second E means times 10. And then that's to the 16th power times 2.4 second E to the negative. Be careful to use negative and not subtract. So -6. So you can just go ahead and plug that in your calculator and hit enter. And it says the answer is 7.44 times 10, because remember E means times 10 to the 10th power. Okay? And we do have an answer that matches, but I also can show you how to use your exponent rules to answer this. So what you could do is you could look at combining your like terms. So you could multiply your 3.1 times 2.4. 3.1 times 2.4, right? And if we do that, 3.1 times 2.4, we get 7.44. Then we could multiply our 10 to the 16th times 10 to the -6. And remember, when we multiply numbers with the same base, you add the exponent. So that's going to be 10 to the 16 plus a -6, plus -6, or 16 minus 6, which equals 10. So you end up with times 10 to the 10th power. So we got the same answer no matter which way you prefer to do it, whether you type it in or you use your exponent rules. Okay, number 7, the font's a little bit small, but I think we can make do. You are building a fence for your garden, and you need to get supplies. You only want to make one trip to the hardware store. So how much fencing material do you need to go around your garden? If the length, so the length is 14/3, and it says the width is 13/2. Okay, you have to be careful. So around, what does around mean? Does it want the area? Does it want the perimeter? Well, around means you want to know how much fence to put around. Okay, so that would be perimeter. And you add up all sides, okay? Be careful. I see sometimes people just add up one length and one width. But really, if you want to go all the way around, you have to add another length and another width. So that means you add 14/3 for this side, and then another 14/3 for the other side, and then a 13/2 for the width, plus another 12/2 for this width. Right? Let me make sure that. Okay, so you could add this up on paper by finding the least common denominator, or you could just go ahead and use your calculator, right? So if you wanted to, I'm just going to use our calculator because it might be a little bit faster. You're going to want to use a fraction. So math scroll over, hitting the arrow keys to scroll over, hit enter, and I'm going to type in 14 over 3, and I'm going to hit over, and then plus, then you have to add another fraction, math over 14 over 3, arrow, plus, so those were our lengths, now we're going to add our widths to that, so 13 over 2 plus math fraction 13 over 2, and because we entered it as a fraction, it gives us our answer as a fraction, and it simplifies it, which is awesome. So you know this is your most simplified fraction. So our answer equals 67 over 3 feet. And it says, keep your answer as an improper fraction and simplify. Well, this is improper. Improper means that your numerator is larger than your denominator and you don't change it to a mixed number. Okay, so we're going to keep it exactly as is, and you could just type that in. Okay? So let's say you guys that you typed it in and you got it as a decimal, okay? And you're like, oh gosh, how do I turn this into a fraction? Okay? So what you could do is, once you have the answer, if you hit math and then just number 1, so hit number 1, it's going to turn your answer into a fraction and it will make sure it's simplified. So if you have a decimal, you can also convert it to a fraction using your calculator. Okay, so moving on to number 8. Give me a second. Okay, number 8 is asking for midpoint. Okay, find the midpoint, and midpoint just means basically the middle or the average. Okay, and we use our equation if we have the midpoint of our x and the midpoint of our y, and that's a coordinate pair, you can find that midpoint by taking the average of your x's. So average means you add up your points and you divide by the number of points. In this case, there's 2 endpoints, so you add them up and divide by 2. And the same thing for your y's. Okay? So we can go ahead and say, well, this is going to be our point 1. So this is x1, y1. And then let's say that this is x2, y2. So we can just plug this into our equation. Okay, so x1 is -3 plus x2 is 5. We're going to divide that by 2, right? And then y1 is -4, y2 is 2, and we divide that by 2. Okay, so now we have it set up, we just have to solve. So -3 plus 5 is going to give us -2 over 2. -4, oops, sorry, this is positive. -3 plus 5, the 5 is bigger. +2. And then over here, -4 plus 2, this one is negative. Okay, and then to simplify, you can simplify 2 divided by 2 is 1. -2 divided by 2 is -1. So now we have to plot this, right? This is our x midpoint and our y midpoint. Okay, so our x value is on this axis and y is here. So first off, x is 1, okay, and then y is -1. So negative will go down. So that means it's going to be right here. That is 1, -1. Okay, so for number 9, guys, we're using the same equation, the midpoint equation, but instead of solving for the midpoint, we know what the midpoint is. We're trying to solve for the endpoint. Okay, so again, you use the same equation up here, same equation, but instead of solving for these 2 values, you're going to solve for one of these values. So I would suggest that you just write them as 2 different equations. You can say your x m value, or your midpoint or your average of x, is going to be your x1 plus x2 divided by 2. And then your y midpoint value is going to equal y1 plus y2 divided by 2. Okay? So do you guys see how it's the same equation, but you just separated your x and your y values? Okay? So now we want to go ahead and plug our numbers in, right? So if this is our midpoint, that means this is our x midpoint, our y midpoint. This is the endpoint. Let's just say that this is the first endpoint. So x1, y1. So that means we're trying to solve for x2, y2. So we can go ahead and just plug in our numbers. So our x midpoint is 6. Our x1 value is -1 plus x2 divided by 2. Okay, and so now we have an equation that we have to rearrange because we need to get x2 by itself. So in order to do that, you have to use opposite operation. So first off, let's get rid of this divide by 2. So opposite operation of division is multiplication. I'm going to put it as a fraction just because it's easier since that's as a fraction. What you do to one side, you do to the other. So now what's going to happen, because we have a 2 in the numerator and denominator, it cancels out. 2 times 6 is 12, and we're left with -1 plus x2. Okay, now opposite operation of -1 is +1. What you do to one side, you do to the other. So we have 13 equals x2. And if that's all you did, you could go ahead and look at your answers and see, hey, I don't have to do any more because there's only one answer with a 13 for your x value. You could be done. But just to make sure, we're going to go ahead and solve for our y. Okay? So our y midpoint value is 5. Our y1 value is -3. We don't know our y2. We divide by 2. Okay? So now we do the same thing where we multiply this side by 2 over 1, multiply this side by 2. The 2's cancel out and we get 10 equals -3 plus y2. Opposite operation. So +3, what we do to one side, we do to the other, +3. So 13 equals y2. So 13 is our answer. And just to give you guys another option, okay, so if the algebra is kind of throwing you off, you guys could just use a number line, okay? So let's look at a number line. This is our x value number line, okay? The midpoint, the definition is it's exactly in between your endpoints. So if we plotted a midpoint for x's of 6, and an endpoint is at -1, let's go ahead and find where that is. So 6, 5, 4, 3, 2, 1, 0, -1. How far away is that? So it's 1, 2, 3, 4, 5, 6. So it's 7 away. So this endpoint is 7 away, which means the other endpoint is going to be 7 in the other direction. So let's go ahead and count that. 1, 2, 3, 4, 5, 6, 7. But where does that leave that? So 6, 7, 8, 9, 10, 11, 12, hey, 13. So we got the same answer by using the number line. Right? So this is 7, just like that was 7. And we could do that for our y values as well. We draw a number line. Our midpoint is 5. The x value that we know is -3, so 5, 4, 3, 2, 1, 0, -1, -2, -3. So how far away is that? It's 1, 2, 3, 4, 5, 6, 7, 8. So 8 away. So that means we have to go 8 in the other direction for the other endpoint because it's equal, right? So 1, 2, 3, 4, 5, 6, 7, 8. And then where is that? So 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. So we just proved that you could use either way. Just use the one that works best for you guys, and you can get the same answer. Okay? Number 10. So number 10, we are solving for the quadratic formula. Okay? And we are given what A, B, and C equals. I would suggest, guys, the easiest way to do this would be to go ahead and plug this into your calculator. Okay? So because it's a fraction, I would suggest that you, let me rearrange a little bit. Because it's a fraction, I would suggest that you make it a fraction. So math, arrow over fraction. Now let's go ahead and plug in our info. So we have a negative b, so you're going to hit negative. Remember, not subtraction, hit the negative sign. b equals 6. So 6. Now the quadratic formula, you actually have to solve twice because it's a plus or minus. So for the first time, let's just do it for plus. Now square root. So second square root button, you see that in blue? Square root. So we need to take the square root of 6. So I'm going to put it in parentheses just in case it's negative, so you don't ever go wrong. So we take the square root of, you square, my apologies, square the 6 minus 4 times A is 1, times C is 5, divided by 2 times A is 1. And you hit enter. Okay, so one of our solutions is -1. And the great thing about your calculator is if you hit second enter, it pops the equation back up. You can hit arrow, arrow, arrow over and just change that plus sign to a minus and hit enter. And you get your second answer, -5. So it's nice and easy if you use the calculator, guys. You just have to be careful with putting the information in correctly. Okay, so let's move on. Number 11. Okay, determine a simplified expression that represents the perimeter of the shape. So perimeter means add up all sides, right? Okay, so let's go ahead and add these up. So we have 3x plus 1. That's one side. I'm going to write it going down to kind of organize my numbers and variables. Then I have on this side 3x. And then over here I have 7 minus 2x. And because I'm putting my x's first, I'm going to really say it's the same thing as minus 2x plus 7. This is the same thing. Order doesn't matter. You just have to bring the signs with it. So the negative came over here, positive 7. So I have minus 2x plus 7. I'm going to add all of those up. 3 plus 3 is 6. 6 minus 2 is 4x. Because remember, when we add numbers with variables, the variable stays the same. You just add your coefficient. And then 1 plus 7 is 8. Okay, number 12. We have a matching question. Okay, so we're using exponent rules. So we need to make sure that we are kind of separating our expressions into our like terms. So we can look at our coefficients first and multiply those, and then we can multiply our variables. So we can do 3 times 5, right? And that's going to give us 15. and then we can multiply x to the 5th times x to the 3rd. When we multiply numbers with variables with the same base or numbers, we add our exponent, so that's x to the 5 plus 3, which equals x to the 8th. So it's going to be 15x to the 8th. Okay, so this one matches. 15x to the 8th. Okay? So let's go ahead and then, okay, so this next one we're doing a power to the power rule. So power to power means you multiply your exponents, and it's your exponents. Okay, so be very careful. So like this 2, even though it doesn't tell you the exponent, you know that the exponent is 1. So you're not going to multiply 2 times 3. That base stays the same. You multiply 3 times 1. So 3 times 1 is 3. Then if you look at your x, your base stays the same, and you take 3 times 5 and get 15. And then you can simplify. 2 to the 3rd power is the same thing as saying 2 times 2 times 2, which equals 8. So this is really 8x to the 15th. 8x to the 15th. We have a match. Okay? This last one we're dividing. So again, you can kind of separate your like terms, and we can divide 16 divided by 2 first. So 16 divided by 2, and we get 8. And then we can take x to the 10th divided by x squared. When you divide, you subtract your exponent. So x to the 10th minus 2 power equals x to the 8th. So our answer is 8x to the 8th. Okay, we solved it. Next, okay, we have a power to the power rule, right? A power to power. So what happens to our exponents? We multiply. And remember, our exponent's not our base. So again, you might want to draw in your exponents to help you. So your base stays the same. So we have 3. And then when we multiply our exponents, 4 times 1 is 4. X stays the same as your base, and 4 times 1 is 4. Y stays the same as your base, and 4 times 4 is 16. Now we just need to simplify. 3 to the 4th power is the same thing as 3 times 3 times 3 times 3 times 3 one more time. Okay, and that would be 9 times 9, which equals 81. Okay, so we get 81x to the 4th, y to the 16th, and we have a match. Okay, so moving on to number 14. We're almost done. So determine expression for volume of the cube. Volume equals length times width times height. So this is our length and our width and our height. So it's going to equal 2x times 2x times 2x. So when we multiply, we can go ahead and multiply our coefficients first. So our 2's, right? And then we can multiply all of our x's together. So 2 times 2 times 2, and x times x times x. Okay, so 2 times 2 times 2 is 8. X times x times x. Well, you can see that you have 3 of them, right?
Teachers, please excuse this interruption, but this is just a reminder there will be a staff meeting at 4 o'clock. A staff meeting at 4 o'clock today.
Okay, so you can see you have 3 of them, so x to the 3rd power, or you can use your exponent rule, right? And when you multiply, you add your exponents. 1 plus 1 plus 1 is 3. Okay, so that means our answer is 8x to the third. Lovely. Okay, so now we want to find, for number 15, find the length of a rectangle if you know that the area is 20x to the third and width is 5x squared. Well, I know that area equals length times width. Okay, so if I plug in some numbers, I know my area equals 20x to the third. I don't know my length, so I'm just going to keep my L. My width is 5x squared. Okay, so now if we want to solve for length, we have to get L by itself. So right now, the operation that's happening between L and 5x squared is multiplication, right? So we need to do opposite operation, which is division. What you do to one side, you do to the other. Okay, and then we can look at canceling anything out that's exactly the same in the numerator as the denominator. So 5 and 5 cancel out, x squared and x squared cancel out. Okay, and then if we look on this side over here, we can simplify. We can take a 5 out of both 20 and 5. So 20 divided by 5 is 4. And 5 divided by 5 is 1, right? And then if we have, let's see, so right here we have x to the third divided by x squared. If we use our exponent rules when we divide, we actually subtract, right? And so we just end up with x to the first or just x. So your final answer, right, you have both of these. Your final answer is going to be 4x. Okay, and you can check yourself, right? So you know length times width equals area. So does 4x times, that's your length, 5x squared, what does that equal? 4 times 5 equals 20. X to the first times x squared equals x to the third. So yes, it does. Okay? So your answer is 4x. Okay, number 16. Answer the questions identifying the parts of the polynomial. So we have a polynomial here. Get a little closer, okay? So we have just some different questions. A, how many terms does this polynomial have once simplified? Okay, so the first thing we have to do is simplify. Okay, so we have, here's a 6x to the third. I don't have any other terms to the third. I have a x squared and an x squared, so those are like terms. And I have an x and an x. Okay, so let's go ahead and combine them just to make it easier. So we have 6x to the third. Now if we combine our x squared, negative 8 plus 12, we're going to be left with 4x squared, right? Because 12 minus 8 equals 4. And then if we look at our x's, 16x plus, this is really a 1x, plus 1x equals 17x, and then we have this negative 13 all by itself. Okay, so now we should be able to answer these questions pretty quickly. So how many terms does this polynomial have when simplified? So terms means the different different terms that are separated by plus and minus signs. So we have 1, 2, 3, 4. So 4 terms, and you just had to type in 4. Write the coefficient of the term that has a degree of 3. Well, the degree of 3 is here, and the coefficient is the number in front of the variable. So 6. What term is constant? Constant means there's no variable, so the only one that's constant is negative 13. Now rewrite the polynomial expression in standard form. Standard means highest degree to lowest degree. Okay, so highest degree is 3, so we're going to put 6 here. And then x squared, so our coefficient already has the x squared, so we just need to write 4. Then we have the coefficient in front of the x is 17, and they already have the minus sign, so we don't have to put a negative 13, we can just write 13.
Students and teachers, I just wanted to remind you that tomorrow is the senior bake sale after school, so don't forget to bring your cash.
Okay, so now we have to evaluate when x equals negative 2. So all we have to do is every time we see an x, we plug in negative 2. And again, for this one, I would definitely use my calculator. Okay, so I'm going to type in 6, and now I have an x. So I'm going to put parentheses negative 2, and that is to the 3rd power. So I'm going to use my caret symbol, caret, and then type 3rd to the 3rd power, okay, and then I hit arrow over to get out of the exponent position, plus 4, now I have x, so negative 2, right, okay, plus 17, and then there's another x, negative 2, minus 13. What do I get? Negative 103. So is that right? Negative 6 to the negative 2 plus... Ooh, I see a mistake. Do you guys see it? I did not put this to the squared, so I can go ahead and redo that. If you caught that, oops, if you guys caught that, awesome job to you guys. Okay, plus 4, negative 2 squared, plus 17. Okay, how does this look? Let's make sure. 6x to the 3rd plus 4x squared plus 7. Yep, okay. So my answer is negative 79. And always go back and check, guys, okay? You never know when you're going to make a mistake, okay? So, number 17, we're in the home stretch. Which of the following represents the given product? Okay, so what we're doing is we have to distribute, right? We had to distribute this negative 7 to both of these values inside the parentheses. So negative 7 times x equals negative 7x. Negative 7 times negative 5. Well, negative times a negative equals a positive, right? So negative 7 times a negative 5 equals positive 35. So plus 35. Okay, so our answer is going to be negative 7x minus 35. Okay, 18. ACT question. Which of the following expression is equal to this minus this? Okay, so the thing that you really have to be careful at is you have to distribute this negative sign. So you're saying I'm actually subtracting each of these terms. So if I have 3x squared minus 4x minus 5, I'm subtracting negative x squared plus 6x plus 7. What happens is I distribute. So this becomes a positive, and then I distribute. So negative times a negative, this becomes a positive. I distribute. This is a negative, negative. Okay, so now, because that's distributed, now I can combine my like terms, right? So first off, let's look at my x's. So we have 3x squared plus x squared. We're going to get 4x squared. Then if we look at our x's, negative 4x plus a negative 6x, we have negative 10x. And then negative 5 minus 7 is negative 12. So do we have anything that matches? I hope so. 4x squared minus 10x. So C would be our answer. Okay, so the key is to distribute those negatives. So distribute the negative to all terms in the parentheses. Okay? So distribute negative to all terms in the parentheses. 19, 2 more to go. Okay, so we have an exponent question, and there's a lot going on, right? Okay, so what we probably want to do is look at combining our like terms, okay? So I'm going to kind of separate it by coefficients, x's, and y's. So we have 8, is that a 6? Yeah. Times 6 divided by 16. Those are our coefficients, right? And then we have x to the 5th, x to the 13th, divided by x to the 6th. And then we have y to the 4th, y to the 3rd, divided by y to the 14th. That might be the easiest way, guys, when you have something so complicated like this, to do this, okay? So first off, we need to simplify this right here. So we could look at, can we take any number out of both the numerator and the denominator? Well, I do know that I can divide 8 and 16 both by 8, right? So I could divide 8 divided by 8 and get 1, and I can divide 16 divided by 8 and get 2. Okay, so then we have 6 over 2, and 6 over 2 is 3. So right away we know 3, 3. We know we can take this one away. We can cross that one out. Okay? So we know a coefficient. So now let's look at our x values. So when you multiply, you add your exponents. When you divide, you subtract. So it's really like saying x to the 5 plus 13, because we're multiplying, but then we're subtracting 6. Okay? So 5 plus 13 is what? Is that 18? 5 plus 13 is 18, and then we subtract 6, so we get x to the 12th. Okay? So then same thing here. When we multiply, we're adding our exponents, so we have y to the 4 plus 3 minus 14. So 4 plus 3 is 7. 7 minus 14, we end up with, I believe, negative 7. Right? Is that right? 4 plus 3 is 7. Okay. So now we have, when we put it all together, we have 3x to the 12th, y to the negative 7th. But remember, we do not like negative exponents. So we have to use our negative exponent rule, where you flip the sign and flip the fraction, right? But that's only for our negative values. So our 3 and x to the 12th stay where it's at, but this y to the negative 7th, we flip it to the denominator, and the negative 7 becomes a positive 7. Okay, let's hope that we did it right. Can we look over here? We have a match, J. Okay, so again, separate your like terms, your coefficients, and your variables, and then just use your rules that you know. Okay, last one. A trapezoid ABCD is graphed in standard form. What is the slope of CD? Well, here is C, and there is D. So we have 2 points. Okay, so we have 2 points. And you know that anytime you have 2 points, you can find the slope, or how steep something is, right? So slope, or M, is represented by rise over run. You may have seen that. Or you may have seen it's represented by the change. This symbol stands for change. The change in y as over the change in x, which also we can write as y2 minus y1 over x2 minus x1. Okay, so now all we really need to do is plug in our coordinate pairs into this equation. So let's just, it doesn't really matter which one is your first coordinate, which one's your second, as long as you're consistent. So let's just say this is x1, y1, this is x2, y2. Okay? So x2 is 1. I'm sorry. y2 is 1, right? y1 is 4. x2 is 12. x1 is 9. Okay, and if you ever have issues with subtraction, right, you can always plug in your calculator. Don't be too proud to do that, okay? So we have 1, or just check yourself. Challenge yourself and check yourself. So 1 minus 4 is going to be negative 3. Let's check ourselves. 1 minus 4, negative 3. Yep. And then we have 12 minus 9, which equals 3. Okay, so our answer is negative 3 over 3. Any number divided by itself, it can just cancel out, so that actually equals negative 1. And so our final answer is going to be B, and that is it for the practice cumulative test for quarter 1. Good luck, everyone.